Algebra 1 skills number 47, linear versus quadratic versus exponential. Okay, so we look at the three and study them, and now we're going to compare the three. Here's a look at the graphs. You should be able to pick out which one's which, though they're intertwined. The linear, of course, is a line. The quadratic would be this U-shaped curve we'll call parabola. Then the exponential graph is flat on one side and steep on the other. But notice what will happen as you get on this side of the screen. Okay, which one seems to be growing the fastest? Which one seems to be growing the slowest? Though you can find them in lots of orders through here. For example, there's a time where the linear is on top of the other two. Over time, it appears the exponential will grow the fastest, the quadratic will be the middle, and the linear will be the slowest. Okay, so that's the theme that we're going to talk about. Now, if you look at their scatter plots, which gets maybe a little into Unit 6 here, linear is, for the most part, a line. It may not be a perfect line, but you definitely can draw a line through there. Quadratic, again, a U-shaped curve, and you see a curve drawn in there. Exponential looks kind of like linear here, but notice there's a definite curve to it. Here, there's and it gets steeper as you go. So one thing would be to get used to seeing those scatter plots. Also, what happens when they race? We talked about it already. But if extended long enough, eventually the following order will happen if all headed in a positive direction. Largest will be exponential, middle will be quadratic, smallest will be linear. Now, if they're all headed in a negative direction, the exponential will get the most extreme. They'll actually get the smallest, so they'll get the most negative of the three. And of course, sometimes you have one headed in a positive direction, one headed in a negative direction, which you don't really think about so much. But the fastest growth is exponential. The slowest growth is linear of the three. If you're looking at table format of them, linear, you're going to be adding over and over. This is a perfect line, is when you add over and over. Okay, now you might have a linear scatter plot, say, where it's for the most part approximately adding. It may not be perfect, but here this is a perfect line. Quadratic is a pattern where you still kind of think add or subtract, but you're not adding or subtracting the same thing over and over. Here you're subtracting 3 and then subtracting 1 and then adding 1 and then adding 3. There's definitely a pattern to it, and the gaps, what we call the second differences, are the same if you were to write those out, but it's not adding the same thing over and over. So quadratic is a sequence which is not looked at quite as much. It's not as easy to detect, but it's a sort of a pattern of adding or subtracting. This is not exactly adding or subtracting the same thing over and over. Then exponential is when you clearly multiply over and over. Okay, so you know again how much faster this is growing than, say, this one, for example. Now, this is used from the State of Georgia Department of Education question. It says, which statement best describes the comparison of the function values for f of x and g of x? So I noticed right away that f of x is definitely linear. You're growing by 2 each time. There's no doubt about it. Meanwhile, g of x is also growing, but if you'll notice, you're adding 1, then you're adding 3, then you're adding 5, then you're adding 7. That's quadratic. Okay, you're adding, and there's a pattern to the adding, but it's not adding the same thing over and over. Okay, so let's look at the 4 answer choices. The values of f of x will always exceed the values of g of x. No, that's not true. We just learned that if they're both headed in a positive direction, then the quadratic will eventually overtake the linear. It hasn't yet. It's still 6 versus 8. But even on the next, if I were to add one more row, the g will exceed the f. B, the values of g of x will always exceed the values of f of x. Well, no, you can see that in the table. Just any of these rows, f of x is on top. So that's not true. Remember, though quadratic does grow faster and will eventually outgrow the linear, it may not at first. C, the values of f of x exceed the values of g of x over the interval 0 to 5. Okay. Now here we can see 0 to 4. We can't see 5, but if we continue the pattern, 5, 10, and then here you added 7, so you're going to add 9 next time. That would be 15. So this is not true. D, the values of g of x begin to exceed the values of f of x within the interval 4 to 5. Yes. Okay, so at some point between 4 and 5, g will overtake f. So D is correct for this one. Example 2, again taken from the Georgia Department of Education website. A table of values is given. What compares the two over the interval 0 to 5? So you can see 0 to 5 here. Now here, this is exponential. You're adding 1, you're adding 3, you're adding 5. No, this is quadratic actually. This is quadratic. Okay, so f of x is quadratic. G of x, you're adding 1, you're adding 2, you're adding 4, you're adding 8, you're adding 16. So it would appear that this one, the gaps are getting bigger quicker than this one. Okay, this one appears to be kind of a version of an exponential. I know you're not multiplying over and over, but it's as if you are and then subtracting a certain amount. That's kind of obscuring it a little bit. But you can definitely see the gaps are widening here. The gap here is 13, whereas it was 8, whereas it was 4. The gaps are growing by powers of 2. They grew 1, grew 2, grew 4, grew 8. Just like you're doubling the gaps. And here you're only adding to the gaps. So doubling the gaps is going to grow faster. Let's look at our answer choices. The graph of f of x always exceeds the graph of g of x over 0, 5. Well, no, because g overtook it right here. Okay, f was winning, so to speak, most of the way, but g overtook it there. B, the graph exceeds, well, no, we just said f was ahead of g most of this. The graph exceeds, the graph of g exceeds f over the interval 0, 4. No, it's the opposite. Right, g, or f is exceeding g. And then D, the graph of f exceeds the graph of g over 0, 4. That's true. But somewhere between 4 and 5, g took over. So this question is very much like the previous question. But by this slideshow, we want to show you that linear is the slowest, quadratic's the middle, exponential is the fastest, and how to kind of detect which one's which and then be able to answer questions and understand that there's going to be an overtaking at some point depending on what functions you have.